This is Algebra 2 Lesson 4-4, Factoring Quadratic Expressions. Now we've done factoring before in Algebra 1. We're just going to do the same thing in Algebra 2, but they're going to assume, and I'm going to assume, that you remember factoring, so I'm going to go through it as if you don't. However, I'm going to expect you to remember it as we go through this, so that it is just really a review for you. Factoring is rewriting an expression as the product of its factors. The greatest common factor, otherwise known as the GCF, is the common factor with the largest coefficient and the biggest exponent. A perfect square trinomial is the product obtained by squaring a binomial. And the difference of two squares is an expression in the form of a squared minus b squared. Now, we're going to look at factoring three different types of trinomials today. The first type is in the form of x squared plus bx plus c. With this type of trinomial, your first job is to find two numbers whose product is c, and those same two numbers must have a sum of b. So we're going to look at our first equation here. If you remember doing this when you were in Algebra 1 with me, okay? We need two numbers whose product is the same as 6 times 1, because the number in front of x squared is 1. And we need a sum of 7. So two numbers who multiply together to get 6, and add together to get 7, which would be 6 and 1. Since the number in front of the x squared, since the number that goes where that little oval type thing is a 1, we really don't have to worry about that leading coefficient, so we just basically need two parentheses, an x here and an x here. Since both of these are positive, it could be plus 6 plus 1, or plus 1 plus 6. Order doesn't matter, sign in front of number does. So there we found the two numbers that multiply together to get 6 and add together to get 7. Now in number 2, I personally do not like to factor a polynomial when the leading coefficient is negative. So if I have a leading coefficient that's negative, I tend to factor it out, like factoring out a negative 1. So that's the first thing I'm going to do here, which means it changes all my signs. I now have positive x squared, positive x, and negative 12, which means I now need a product of negative 12 and a sum of 1. Two numbers that multiply together to get negative 12 and add together to get 1. Okay, since I need a positive 1 versus a negative 1, I know my positive number has got to be larger than my negative number. So this would be positive 4 and negative 3. Again, keep your negative 1 because you factored that out to begin with. And again, we're going to have two parentheses, an x here and an x here. And now I would simply put in a plus 4 and a minus 3. Sign goes with its number. So we now have negative 1 parentheses x plus 4 parentheses x minus 3. That's factoring in the form of x squared plus bx plus c. Now, sometimes we need to look at things to see if there's common factors first. In this problem, next 7n squared minus 21, I know that the greatest common factor is 7. So if I take out a 7, I'm going to be left with n squared minus 3. That cannot factor again, so I'm done at that point in time, because I know that 3 is not a perfect square, so I can't factor that any further. In problem number 2, I look at that and say, what's my greatest common factor? Well, 9 is divisible by 9, and 18 is divisible by 9, so I'm going to take out a 9. And I'm left with x squared plus x minus 2. Now I have to look at my trinomial that's inside my parentheses and see if I can factor that again. I need a product of negative 2 and a sum of 1. Okay, so if I look at that, I go, product of negative 2, sum of 1. That would be positive 2 and negative 1. So this can factor again, so I'm going to end up with 9 parentheses x plus 2 parentheses x minus 1. And now I have factored that trinomial all the way down. Number 3, not only can I take out a number, but I also can take out a variable. The greatest common factor out of the largest number that will divide evenly into 4 and 28 is 4. And the greatest number of x's I can take out of x squared and x is just an x. If I take that out, 4x squared divided by 4x is just x. And 28x divided by 4x is just 7. So I left with 4x parentheses x minus 7. Okay. Now, factoring gets a bit more complicated when you have a leading coefficient other than 1. In other words, when things are in the form of ax squared plus bx plus c. Now there's different and varying ways to factor, but there's one specific method that I like because it works really well without having to do any guess and check. I'm not even sure if this method is discussed in your book. I didn't even pay attention to whether it was or wasn't. because this is the way that I like to factor, because it eliminates all kinds of guessing. It takes it right down into factoring by grouping. So we're going to form a product of A and C, that's the first term and the last term. And we need to find a pair of numbers whose product is that, but whose sum is the middle term of B. So if I look at problem number 1 here, I need a product of 30 with a sum of negative 17. It's kind of squishing in there. So I need two numbers that multiply together to give me 30. That would be A times C. There's A times C. And whose sum is my middle term of negative 17. Now I look at that and I go, oh, negative 15 and negative 2. Negative 15 and negative 2 add together to get negative 17 and multiply together to get positive 20. Now what am I going to do with this negative 15 and this negative 2? This negative 15 and the negative 2 are going to replace the negative 17 in the middle. I keep my first term, 5x squared. I rewrite negative 17x as negative 15x minus 2x, or negative 2x minus 15x. The order doesn't matter. And then I add the lesser term plus 6. Now I have a 4-term polynomial. With a 4-term polynomial, we're going to group it. Right? So I group first 2, last 2, and I put a little plus sign between them. Okay, because sign goes with its term. So now I have 5x squared minus 15x plus parentheses negative 2x plus 6. So I'm going to look for a greatest common factor of just my first term. So the largest number and variable that can come out of 5x squared minus 15x is a 5x. If I take out a 5x out of that first parenthesis, I'm left with x minus 3. In the second parenthesis, I'm looking for the greatest common factor out of negative 2x plus 6. Remember what I said, if my first term is negative, I'd like to take out a negative to eliminate the leading coefficient being negative. So I'm going to take out a negative 2, and I'm going to be left with minus 3. Which is good, because when I take out everything, what I want to have is I want to have a common term. And there it is. My x minus 3 is my common term. It's common to both parts of this grouping of this polynomial, so I take it out once, x minus 3. And then whatever's left over, I write as my second part of my polynomial, 5x minus 2. It's called factoring by grouping, and it works really, really well, and eliminates the guess and check method. Okay, for those of you who do not guess and check well, this is a faster method. Let's look at number 2. We need a product of negative 24 and a sum of 5. I'm going to do this in a different color so you can see a little bit better. So I need two numbers that multiply together to get negative 24 and add together to get 5. That's positive 8 and negative 3. So I'm going to rewrite this as 2x squared plus 8x minus 3x minus 12. Group it first 2, last 2. My common term out of my first parenthesis is 2x. If I take out a 2x, I'm left with x plus 4. Common term out of the second parenthesis is negative 3, and I'm left with x plus 4. So I have my common term, x plus 4, and what is left over, 2x minus 3. And I have factored that polynomial. The more you do these, the better you get at them. If you have me for Algebra 1, we factored using this method, and it should be coming back to you now as a bad dream for some of you. All right, let's look at number 3. Number 3, I need a product of 24 and a sum of 10, which is 6 and 4. 6 times 4 is 24, 6 plus 4 is 10. So 3x squared plus 6x plus 4x plus 8. Group first 2, last 2. I can take a 3x out of my first term, and I'm left with x plus 2. Out of my second term, I can take out a 4, and I'm left with x plus 2. So my common term is x plus 2, and I'm left with 3x plus 4. Now, a lot of times in algebra, this is where we would have stopped on the very first day. However, this is Algebra 2, and this is a review. So we're going to continue just a little bit further here. Okay, these two problems here, before I even start looking for product and sum, the first thing I'm going to do is I'm going to look at that and go, wait a second. They have a greatest common factor. I can take something out of it. You should always look to see if a number has a greatest common factor, because if it has a greatest common factor, take that out first. It will make your problem much, much easier. So in problem number 4, I can take out a 2, and I'm actually going to take out a negative 2. We've already discussed how much I hate having a leading coefficient that's negative. So if I take out a negative 2, I'm going to end up with 2k squared plus k minus k minus 15. So now I need a product of negative 30 and a sum of negative 1. So negative 6 and positive 5. So I'm going to have 2k squared minus 6k plus 5k minus 15. And all I did was rewrite negative k as negative 6 and positive 5. Group my first 2 and last 2 again. Common term in the first one is 2k, and I'm left with k minus 3. Common term in my second parenthesis is 5, positive 5, and I'm left with k minus 3. So my common term is k minus 3. My leftover term is 2k plus 5. But I can't forget that I took out a negative 2 to begin with, so I need to take that negative 2 out at the end. So I have negative 2 parentheses k minus 3 parentheses 2k plus 5. All right, I'm going to skip number 5 so we can move on. You can do that on your own, and I expect you to do it on your own in your notes. All right, now here I got a small little error here with my, I got a little happy with my x's. There should not be an x here, and there should not be an x here. It should just be a squared plus 2ab plus b squared here, and it should be a squared minus 2ab plus b squared here. Right? So perfect square trinomials. To determine if something is a perfect square trinomial, you look at your first term, you look at your last term. If your first term is a perfect square and your last term is a perfect square, you're step 1. The next thing you do is you look at your middle term, and your middle term has to be 2 times your first term, the square root of your first term, and the square root of your last term. For example, if I was to look at x squared minus 16x plus 64. Right? If we fit into these formulas, my a term is going to be the square root of x squared, which is just x, and my b term is going to be the square root of 64, which is 8. Is my middle term 2 times a times b, or the opposite of 2 times a times b? Well, a times b is 8 times x, which is 8x, times 2 is 16x. My middle term is negative 16x, so it works. This is a perfect square trinomial. Since there's a negative here, we're going to use the negative formula, this one right here. So it's going to be a minus b times a minus b. So my a term is x, my b term is 8, so a minus b times a minus b, or you could write that as a minus b quantity squared. Okay, let's look at number 2 here. My a term is the square root of 64x squared, which is just 8x, and my b term is the square root of 1, which is just 1. 8 times 1 is 8, times 2 is 16, so yes, this is a perfect square trinomial. Again, it's got the minus sign, so I'm going to use the negative formula. If it had a plus sign, I'd use the a plus b times a plus b formula. Since it has a minus sign, I'm going to use the a minus b times the a minus b formula. So this is going to be a minus b times a minus b, or a minus b quantity squared. Oops, I got 31 for my keys. Okay. Number 3. If I look at this, my leading term is negative. I can't deal with that. So I'm going to take a negative out of it. I'm going to get 25p squared minus 30p plus 9. So my a term is the square root of 25p squared, which is 5p. My b term is the square root of 9, which is 3. So I have 5p minus 3, again, because my middle term is negative, times 5p minus 3. Don't forget we took a negative 1 out to begin with, so we have to put that back. So it's either that or it's negative 1 parentheses 5p minus 3 quantity squared. Now there's a pattern to the difference of squares. A binomial is a difference of squares if and only if both ax squared and c are squares and ax squared and c have opposite signs. Okay? So if I look at this, they have to have a, in other words, I have to have a minus sign between them, or the first term has to be negative and the second term has to be positive. So if I'm factoring the difference of two squares, the first term has to be a perfect square, which this is, and the second term has to be a perfect square, which is this, and they have to have opposite signs. 81x squared is positive and 100 is negative, so they have opposite signs. So I simply figure out that my a term is the square root of 81x squared, and my b term is the square root of 100. Remember, it's not the square root of negative 100. You let the formula take care of your positive and negative signs. So the square root of 81x squared is 9x, the square root of 100 is 10. So you get 9x plus 10 times 9x minus 10. Number 2 here, again, always look for the greatest common factor. I'm looking at this going, yeah, the first term is positive and the second, or perfect square, and the second term is a perfect square. However, there is a greatest common factor of 4 here. So I'm going to look for my greatest common factor of 4 and take that out. If I take my 4 out, I'm left with x squared minus 4. So now, my a term is the square root of x squared, and my b term is the square root of 4. The square root of x squared is x, and the square root of 4 is 2. So I have x plus 2 times x minus 2, or x minus 2 times x plus 2. But don't forget you took out a 4 to begin with, so we have to put that 4 back in to our equation when we're done. Last but not least, right? Negative x squared plus 196. Also a perfect square. But I hate dealing with that negative sign in the beginning. So I'm going to take a negative 1 out of that and make it x squared minus 196, which is perfectly fine. So my a term is the square root of x squared, which is x. My b term is the square root of 196, which I believe is 14. Check on that. Yep. So then I can do my a plus b times a minus b, and of course I took a negative 1 out, so I have to put that back into my equation. So this is all the type of factoring that you actually learned in Algebra 1. It's just a review here for Algebra 2 because you're going to use it quite frequently throughout the rest of this chapter.